running Microsoft and AWS. It's not an oxymoron. It happens all the time. Let's hear more about this from Andy.
All right. Good morning, everyone. Like Ron said, my name's Andy Hopper. I'm a specialist SA here at AWS. Before I came to AWS, I was actually a software developer in the Microsoft world for about 25 years. So I love talking to people about how they can successfully run their applications in AWS, and why, in fact, I believe the AWS is, in fact, the best place to run your Microsoft workloads. So just a quick overview of what we're going to be talking about in this session. We'll talk a little bit about how we build our infrastructure to and why we do believe that we're giving you guys the best environment. We'll cover things like reliability, performance, what your options are for running things, and then we'll dive into a little bit about what once you move your workloads into AWS or you implement things on AWS, what does it look like to engage in the care and feeding of those applications? Because after all, migrating is one thing, but once you're there, you have to make sure that you're able to continue to be successful once you have your applications up and running inside AWS. So let's talk a little bit about AWS's experience running Microsoft workloads. Our CEO, Andy Jassy, has a great saying that he's famous for, which is, there is no compression algorithm for experience. And what this means effectively is that there are lessons that you just don't learn until you've been running things at scale for a long time. I'll be forthright. We AWS, we've occasionally had our own operational issues. Every time we have something like that, we learn from it. We learn it, we do root cause analysis on it, we use it to make our operations better. Our goal is to give you guys, seamless reliability of all of your services. We want to get as close as possible to 100% operational excellence for you guys, so that you can focus on delivering the things that make your business special, as opposed to having to worry about the care and feeding of boxes that that your applications are running on top of. So what does this look like? So we've been running Windows on AWS, frankly, longer than Microsoft has even had a cloud. The first time you were able to run Windows on top of AWS was 2008. Azure was just coming out as a beta. So we have been operating Microsoft workloads so long that we're actually helping to teach Microsoft how to best operate Windows inside the cloud. So what does this look like for you? Well, like I said, back in 2008, we supported 2003, which was still being used by lots of people, and 2008 was just coming off the presses. And over time, you'll see that we've been adding more and more operating systems from Microsoft into our platform, all the way up to the most recent releases of Windows Server 2019. Now, we didn't stop there, of course. In most applications at some point are going to need to talk to some kind of data platform. And we also support the ability to not only run SQL Server, which is Microsoft's database platform, on top of our cloud. We've also got services that make it to where all you need to do is press a button and we'll create a SQL Server database for you. It's called Relational Database Services. And what this allows you to do is have your DBA stop worrying about the spindles that your databases are running on, or keeping the operating system patch. And instead, you get to focus on the things that are actually special for your application, as opposed to the undifferentiated heavy lifting of operating a SQL Server database. On top of the core infrastructural things, we of course have lots of services for helping you develop applications. So, we supported .NET back in 2008. It was, already being delivered on the Windows platform. And over time, what we've done is add more and more capabilities to the AWS platform, all the way to the most recent versions of .NET. So I don't know how much of you guys have been paying attention to it, but Microsoft has indicated that this new platform, .NET Core, is now the future of .NET. Everything that's .NET Framework is now legacy, and we have excellent support for .NET Core on our Linux operating systems, and our containerization platforms, and our serverless technologies like Lambda. And then finally, when you are looking at how you're going to deploy this infrastructure on top of AWS, we give you a plethora of choices for how you operate that. I mentioned, the options for doing things on top of a virtual machine platform. We call that Elastic Compute Cloud, or EC2. You've got containerization options such as our Elastic Container Service, or even Kubernetes. If your folks have already started going down the path of using Kubernetes for orchestration, you've got a lot of different options for how you can run it. Incidentally, while we definitely will always, excel and offering more platforms, there's always a choice about, what the best one for your workloads are. That's where guys like me come in. So always feel free to reach out to your solutions architect, help us understand what your workloads look like. We'll help guide you through the process of deciding where the best way to run your workloads in AWS are going to be. On top of all this, we also have a lot of different ways you can configure Windows. So Windows by itself can come with a lot of different optional features. Not everything needs IIS, for example, or sometimes you want to have Windows and SQL Server on the same box. We've got different configurations already set up and ready to go for you, as opposed to you having to manually go and install those things. So it allows you to get up and running very quickly while getting the infrastructure that your applications need in order to be able to function. Now, I just wanted to show you guys this graph. This is still, it's a relatively old study, but it's still the most recent one that we've currently got. They did a survey of all the people who are running Windows, and these are actual operational Windows workloads that are up and running inside the cloud. And at the time, they found that we almost double the amount of infrastructure, Windows-based infrastructure, that's being run even in Microsoft's own environment. And the reason for that is how we've built our infrastructure and basically our record for operational excellence. So let's dig into that a little bit. So what this map is intended to represent is just the overall presence that AWS has globally. We just announced our most recent region in Milan, Italy. So we now have 24 regions around the globe, and those have 76 availability zones. We'll talk a bit about availability zones in a moment. But we also have 3 regions that are coming up. One that's going to be announced pretty soon in Jakarta, in Indonesia. We have another one in Osaka, and yet another one that's being planned for Spain. And what this means for you is that you get to decide where you want your infrastructure to run and ensure that your customers will have the best experience by leveraging infrastructure that's as close to them as possible. Now, while we're talking about that, if you are talking about delivering content to your customers, you probably need to be thinking in terms of things like content distribution networks. And we have a service called CloudFront. It's a CDN that Amazon operates, and we have over 200 points of presence around the world. And we also have regional edge caches to be able to deliver things like static media or video assets to your customers, so that they get time to first byte experiences that are as close to single-digit milliseconds as they possibly can. Now, all the white lines you see here on this chart, these are Amazon operated links. So you'll notice that we've got, in many cases, multiple redundant links that go between these. And a lot of people ask, why? Why is Amazon building their own backbone? And there are a lot of reasons for it. First and foremost is security. The internet is a harsh place. It's the Wild West. There's lots of things that can, people want to sniff on your traffic and whatnot. And what we want to do is ensure the highest security network we possibly can in between our regions. And so when you are doing intra-regional communications, between, say, the Virginia US East 1 region and, say, the West Coast, which is, in California, that's going to be traversing an Amazon backbone as opposed to going over the internet. Another benefit of this approach is availability. By virtue of the fact that we actually control all the networking links, we have the ability to monitor those in real time. We're not waiting for a provider to tell us that there's an issue or a service outage. Our own infrastructure is being monitored by us, and so we've got the ability to be able to move traffic back and forth between those redundant links in order to ensure that your customers see absolutely no disruptions in the case of a backhoe. Because let's be frank, backhoes do happen. I've been on the receiving end of those many times in my career. Of course, the other one is just simply the reliable performance. What you don't want to do is have your application be affected by the new release of Netflix's Stranger Things. You want to ensure that you've got consistent bandwidth between all of your application components. And again, by virtue of the fact that we control that network, we're able to ensure that we've got a very good quality of service, between all of your infrastructural components. And then the last one, and this is kind of a benefit of having control over those points of presence for our CDN, it allows you to get your content very close to where your end users are, so that when they're in their web browsers and interacting with your applications, they get a seamless interaction with it as if it was running inside their own WAN. So again, all the standard benefits you would get with a CDN. Incidentally, one thing I wanted to point out is, again, all traffic in between our individual regions does traverse our own backbone. There, you'll notice there's an asterisk there. There is an exception when it's going, inside the Republic of China, and that's simply due to governmental restrictions inside the China firewall. So I'm not going to spend a huge amount of time digging into the actual regional design because I want to focus on the Microsoft aspects, but this does bear on reliability, so bear with me for just a moment. I mentioned we've got 24 regions around the world, and each of those is set up to have redundant connectivity to the internet, and they have multiple what we call availability zones. So think of an availability zone logically the same way you used to when you were thinking about data centers in an on-premises world, except in our world, an availability zone, it may not necessarily be a single data center. It could actually be a logical cluster of data centers. And what we did with regions is every single one of our regions has multiple availability zones. So what does this mean for you? Well, number one, they are geographically separated. They're all within about 100 kilometers of each other, or 60 miles roughly. So what this means is if you have workloads where you want to make sure you've got good geographic separation between the data centers that are hosting your infrastructure, you can oftentimes achieve that within a single region. The other thing that's really important is with these availability zones, they've got their own independent power. They've got their own independent network connectivity. When applicable, we have them running in different floodplains on different fault zones. And the whole idea is that anything, backhoe, natural disaster, whatever, power outage that could take out a single availability zone is very unlikely to take out all the neighboring availability zones inside that same region. And so what this means for you, the people who are delivering this kind of application, is that you can achieve high availability just by leveraging the fact that each of our regions provides multiple availability zones and distributing your resources across those availability zones in the regions that you're actually going to be leveraging. So what does this mean? Well, back in 2018, there was a survey of all the public cloud providers, and this is publicly available data, so we didn't fudge any numbers here. They just, looked at the amount of downtime that, Azure had versus AWS, and we had 7 times fewer downtime hours. And the reason for that is simply, again, getting back to that no compression algorithm per experience. We have learned lots of lessons. We deliberately built our infrastructure from day one to be highly redundant and to be highly operable, and you customers get to benefit from that by virtue of having much better uptime by leveraging AWS's infrastructure. So let's talk a little bit about performance. We are continually trying to find better ways to deliver our infrastructure to you, the customers. And one of the things that we've done fairly recently, this is a couple of years now, is introduce a new concept called Nitro. So, bear in mind, when you're running a workload on top of AWS, you often could be using our virtual machine infrastructure. And for those of you who are familiar with virtualization, there's something called a hypervisor. You can think of it as the operating system that's underneath the operating system that your application is running on. And this is not free, right? There's always some amount of overhead that comes with operating, that hypervisor, so you could have a bunch of virtual machines on a host. Well, what we did with the Nitro system was we found ways to offload a lot of the operational overhead that comes with operating a hypervisor into actual hardware. And what this means for you is that you get access to more and more of the underlying capabilities of the host that's running those virtual machines. And our goal is to get you as close as possible to 100% of the actual horsepower of the box. Another advantage to the Nitro system is that by virtue of the fact that it's all done in hardware, it means that it's a lot less vulnerable to bad actors who are trying to inject some kind of fault or do any kind of hacking of the underlying hypervisor, rather than running it as software that is possible to have fault injection or buffer overruns or whatnot. It's actually baked into the chips so that the code that's being run cannot be modified. So when you actually look at what this looks like, when you look at an individual, Elastic Compute Cloud instance, what you'll see is we've got the Nitro system, and incidentally, Nitro is able to provide not only, optimized access to the underlying hardware, but we can also do things like offloading network overhead to make the overall performance better. We have the ability to access local instance storage in the way of NVMe drives. So I don't know how many of you folks are familiar with, what is it, the non-volatile memory express technology that allows you to have super high bandwidth to local storage, even higher than you can get with serial ATA. And on top of all that, that's also where all of our network management infrastructure is running. So we're not using any of the resources of the machines that you're, that you're running inside AWS in order to actually manage them. And instead, we're letting the Nitro card actually manage all of our monitoring infrastructure to ensure that your hosts are available. So let's talk for a little bit about the network. I'm almost done about infrastructural stuff, and we'll get into Microsoft in a moment. But if you actually look at the network that we're providing to you guys, we've got our own proprietary networking technology, and what these are doing is providing super high bandwidth to the EC2 instances that you've got inside our availability zones. And as a matter of fact, if you've got a workload that needs very high, high throughput, low latency connectivity between your instances, maybe you're doing, a high performance computing platform, or maybe you're doing real time, artificial intelligence or machine learning, where you need that kind of high throughput network capability, we have a concept of something called a placement group. You can think of it logically the same way you would as, co-locating a bunch of servers inside the same rack inside a data center. What we'll do is, if you indicate that you have instances that want to be inside the same placement group, what we will do is ensure that we get those machines as close to each other as possible. And in some cases, they literally can be inside the same rack inside one of our availability zones. Also, we have the ability for you to select instances that have what's called enhanced networking. And what we're achieving now is up to 3 million packets per second coming to and from these instances. And again, this is fantastic when you're doing things that require very high throughput or low latency networking. Again, for things like high performance computing, the ability to do real-time analytics on data flows, that sort of thing. Another thing I wanted to point out was, on top of all this, with the, with the enhanced, capabilities we've got with our EC2 platforms, with Nitro, with our enhanced networking, what this means is when you want to run workloads such as, say, SQL Server, which really will tax your hardware to its extreme, we're finding that you can actually get 2 times better performance, price per performance numbers on top of AWS than you can with Azure. And you can actually read the results. This is actually an independent third party who, did a benchmarking survey on top of SQL Server, and they compared running SQL Server on top of Amazon EC2, so this is natively running on top of Windows, and they simply compared it to a similarly configured machine running inside the Azure environment, and then ran a series of benchmarks against it. But again, don't take my word for it. Please go ahead and follow up and read this. And incidentally, you will get copies of this deck, so don't worry about needing to take screenshots of all these links and whatnot. So let's talk a little bit about the flexibility of the platform. We've got the broadest platform choice that you could possibly ask for. We've got various categories of virtual machines that you can host your infrastructure on. We've got, general purpose servers. These are the kinds of things that if you called up Dell and asked for an off the rack server, it'd be that sort of box. However, depending upon your workload, you may need very high throughput to underlying disk storage. Let's say you're doing, log analytics and you need to do ingestion of logs at a very high throughput. Or maybe you're, running a memory intensive application like SQL Server. SQL Server loves memory. And so you want, or even SAP, for example, where you've got an application that has, super memory intensive workload, and you need a box that's capable of hosting terabytes of RAM. We've got the ability, if you go all the way up to 16 terabytes right now on our platform. On top of that, we also, offer multiple types of processor now. So it used to be that we only offered the Intel chipset, but now we've been working with AMD. So in advanced micro devices, we support their x86-64 platform. And a couple of years back, we just announced our own CPU. It's called the Graviton processor. This is an ARM64 chipset. Why would you be interested in something like this? Well, it turns out ARM is actually a very cost-effective way to run lightweight compute, workloads. These are things like web application servers, containerized platforms, that sort of thing. And on top of that, we're finding that people are able to save up to 40% running similar workloads on top of an ARM64 platform as they were running it on top of Intel x86. And then lastly, when it comes to, the, very highly specialized workloads, sometimes you may be, running something that requires access to things like graphics processing units. We've got the ability for you to get optimized access to NVIDIA GPUs. So if you're doing machine learning or if you're doing training of models, that sort of thing, you can leverage a GPU chipset. Or maybe you've got something that's highly application specific and you need to run it on a floating point grid array. We offer instances, FPGA instances that allow you to actually customize the underlying hardware or firmware, that is, so that your application can get access to very high compute capacity. And what this all boils down to is, why people are coming to AWS from Microsoft. Again, we've got the most experience running Windows on top of AWS. We've got the best global availability that your customers could need, running across 76 availability zones across those 24 regions. We have over 89 security and compliance resources. We were talking about security earlier today. Incidentally, if you are an AWS customer, you can get access to all the certifications that we offer you through a service called Artifact. By virtue of the fact you've signed up for AWS, you have an NDA, and so you're able to access all the data we expose. We have over 212 service offerings now, and this is accelerating year over year. We're continually adding more services that make it easier for you to build complex applications on top of AWS. And then lastly, if you look at, overall price, we now have had over 81 price reductions since 2006 when we started the platform. And I should point out, our price reductions largely come without any, market competition. What we're finding is as we get better at operating workloads inside AWS, we find ways to achieve better margins, and so our overhead gets lower. And when we find that our overhead gets lower, we pass those savings on to you, the customer. Why do we do that? Well, we're doing it because no one has ever come to us and said, hey, I love all the services you have, but I sure do wish I could pay more. No, of course not. Everybody wants to be able to pay less using the same kind of infrastructure. And what we find is it's a win-win. We pass the savings on to you. You guys are happy because your overall operating margins get lower. And then you stay with us because you begin to trust us as a partner as opposed to a vendor. And what I wanted to show you guys here were these are just a couple of customer references that were just talking about, how easy it was for them to migrate their workloads into AWS and the kind of success that they're having. I won't belabor you guys by reading all these quotes verbatim. Again, what we'll do is we'll give you guys access to the PDFs, and you'll be able to access the links that are in here, so you can either read the documentation or watch the videos that have the customer references in there. So let's talk a little bit about what this looks like once you get things inside AWS. So really, when you think about it, there are three main categories when you're running a workload inside of any environment, right? You've got to figure out, what are you going to do about your applications? Are you going to modernize them? Are you just going to do what's called a lift and shift? Are you going to be doing any kind of upgrades while you're doing this kind of migration? And then lastly, once you've got something like, in your operating environment, what do you do to manage it? How do you monitor it? How do you keep it healthy? So let's dig in a little bit here. So when it comes to building modern applications, I mentioned earlier, we've got fantastic support for Microsoft programming environments. To wit, we have a fantastic developer experience for .NET. And what this allows you to do is, leverage our SDK. We have both software development kits for the .NET platform as well as the .NET Core platform. And you'll notice that we've got very good support for all the classic development environments that your developers are typically going to use, whether that's Visual Studio Code, Visual Studio on the desktop, or technologies like PowerShell, where people are trying to script the the kind of management things that they need to do using the .NET platform. In addition, when it comes to defining the infrastructure in AWS and how you get it deployed, not only do we have services like CloudFormation, that's our infrastructure as code service, we also have support for writing your infrastructure literally as code. So we have something called the Cloud Development Kit. And what this will let your software developers do is, rather than learning a whole new dialect for how to describe the resources that your application are going to run on, they can instead write C# code, and that C# code will actually compile down to the descriptions of all the resources that the application need. So this means that your software developers can stick with the tools and technologies that they're familiar with, and yet be able to start interacting with AWS resources in a very quick manner and using the same tools that they're already used to. And I mentioned earlier, we've got customized, Amazon machine images or AMIs for, running various Microsoft workloads in AWS. We also have, optimized AMIs for running things like .NET Core or even Mono inside the Amazon Linux environment. And we also have support, for not only our own distro of Linux, it's called Amazon Linux. You can think of it basically as a fork of Fedora, but we also support other, operating systems such as Ubuntu, CentOS, SUSE Linux, that sort of thing. So let's talk a little bit about migrating and modernizing your applications. So we offer a broad array of migration tools. We've got things that help you determine what's actually running inside your data centers. We have technologies like Cloudimize, which will help you actually do an analysis of what you've got running and tell you what the like-for-like equivalents would look like inside AWS. We have services like Application Discovery Service, which will actually help you discover what's actually running inside your data centers. But we also have services like Control Tower and Landing Zone. These are ways for you to actually structure your Amazon environment and prepare them for running your workloads. What you'll often hear us talk about as you start doing more and more with AWS is something we call the multi-account strategy. It turns out that running everything inside one single AWS account is not always the best idea. What you frequently want to do is, just like you have your own like development, UAT, and production environments, you actually want to adopt a very similar concept when you're looking at running your resources inside AWS. And so when you think about that, this is where technologies like Control Tower and Landing Zone really come in. It gives you a very easy way to set up those environments so that your developers and your operations guys are able to safely and securely deploy resources without having to worry about whether or not they've properly configured each of those accounts. And we're going to be talking a little bit later about migrations, but we have technologies like Cloud Endure. This allows you to take an application that's running on a box inside your data center and literally create an instance inside AWS that's running the exact same configuration. But again, I'll let Mahesh talk about that in the upcoming session. We also have services like, server migration service. You can think of this as like a VM import, if you will. So if I've got a Hyper-V or a VMware box, and I want to make sure that I'm able to run this inside my AWS environment, server migration service is able to take that image and convert it into something that can run on top of our Elastic Compute Cloud. And then lastly, there's operations. Not all customers, feel comfortable trying to run their own infrastructure. And to support that, we have something called AWS Managed Services. What we will do with AMS is we will actually operate your AWS environment for you. And when you need to have any kind of modifications, or if you're going to stand up a new application in it, you literally just cut a ticket to AMS, and then they will provision the infrastructure necessary to run your applications. So it allows you to kind of offload the overhead of managing that infrastructure onto us, as opposed to having to have your own guys manage that. So the next is, not only is there migration, but sometimes you want to re-platform. So case in point, a lot of people don't realize that SQL Server now runs quite well on top of Linux. So why would you be interested in something like this? Well, it turns out if I'm running SQL Server, of course I'm leveraging SQL Server, so I'm totally willing to pay the license for that. But am I actually leveraging the Windows operating system for this? Not really. I just wanted to have a way to run SQL Server. And so by hosting SQL Server on a Linux operating system, I can actually lower my overall costs because I'm no longer having to pay for the Windows license so I can run that SQL Server box. The management experience is largely the same as running SQL Server on Windows. You use the exact same management tools, SQL Server Management Studio. Your DBAs can still talk T-SQL and all the other tools that they're used to using for managing SQL, but they, again, you no longer have to worry about keeping that Windows license active. And on top of that, if you're running other workloads on top of Linux just to achieve better cost savings, now you've got the exact same platform across not only the application servers, but now also on the same box that's serving your database up. So let's talk about containerization. So, up until now, I've been talking about running things on virtual machines, but a lot of customers are finding that they'd prefer to run their Windows applications or their .NET applications on top of a container. We actually another survey was done, this is a couple of years back, and what they found is 63% of the container workloads that are hosted in the public cloud are currently running on top of AWS. And in addition to that, if you look at just the Kubernetes landscape, Over half of the Kubernetes workloads that are running in the public cloud today are running on top of AWS. And again, the point I'm trying to emphasize is, again, no compression algorithm for experience. We've been doing this longer. We have the best tools for managing containerized applications. And so we want to give you guys the ability to leverage that expertise in your own applications. Now, I mentioned earlier, sometimes when you're migrating an application, there may be pockets of opportunity. Case in point, SQL Server 2008 is no longer, being supported by Microsoft. They deprecated 2008 and Windows Server 2008. And so what we're finding is a lot of customers who are in the path of lifting and shifting workloads from their on-premises environments into AWS. They want to go ahead and modernize the operating systems and the underlying database platforms. We've got processes in place that make it very easy for you to take those existing workloads, get them modernized to a more recent operating system inside the AWS environment. And the two links we have below here are just the upgrade guides that we've got for how you can go through the process of step-by-step, taking your workloads, upgrading them as you're doing your migration, and then verifying that everything is going to continue to work once you've got that upgrade in place. And then the last thing I really wanted to mention, on this trifecta was just management. So, once you're running things inside AWS, you have to think about operations. And so we've got technologies like something called AWS Systems Manager. Systems Manager is a free service to you. So if you're using our Elastic Compute Cloud as a platform, you're able to use Systems Manager to keep your systems up and running. I should also point out, Systems Manager is not just for the AWS cloud. If you have on-premises instances that you want to manage and you want to use the exact same tooling, Systems Manager has an agent you can install on your on-premises and on data center boxes so that you can have a single pane of glass for both your cloud-hosted resources as well as your on-prem resources. And on top of all that, Systems Manager supports something called Session Manager. So in a lot of cases, when you're running things that are inside private subnets in the cloud, there used to be this concern about having to open firewall holes to allow management access, or you had to run something called a bastion host, which was a box, you could also call it a jump box. But this was a machine you'd have to shell into so you could shell into your other machines. Session Manager actually allows you to completely eliminate that unnecessary layer of bastion hosts and actually establish a secure connection directly to the machines, regardless of where they are. And by the way, Session Manager works not only, again, in the AWS cloud, it can also be used to manage your on-premises infrastructure as well. And then the last thing I wanted to mention for Systems Manager is we have something called Patch Manager. So if you're running Windows or Linux operating systems, one of the concerns that you should be thinking about is how do I ensure that I'm guarding against zero-day exploits or the latest CVE? What Patch Manager is able to do is not only inventory the machines you have in your environment, but ensure that they've got the latest and greatest security patches applied to them to ensure that your workloads are going to be kept safe. We talked a little bit about compliance in the security section, so I won't dig super deep into that. But one thing I did want to point out is a service of ours called License Manager. So one of the things that you should be thinking about with your Microsoft workloads is how do I ensure that I'm not going to have a costly audit of all my Windows licenses or my SQL Server licenses. License Manager actually gives you a very easy way to track license consumption across your resources, whether they're hosted inside AWS or in your on-premises environments. And then the last thing I wanted to mention was just how do you monitor these things? So we have services such as CloudWatch. We also, I mentioned, as Systems Manager, we can also keep track of what boxes you've got running inside your environment. And we have a broad range of tools for it. But in the interest of time, I'm not going to dig super deep into what all of those are. So let's just kind of close things out here because we're wrapping up on the end of my time. So when it comes to running Microsoft workloads inside AWS, one thing that I wanted to underscore to you folks is you don't have to go it on your own. We have a broad range of partners who are achieving Microsoft workload competency. We have something in the partner network. We have a way to actually certify that our partners are capable of reliably delivering services on various aspects of technology. And so if you go to our APN network page, you can actually look up, this is just a sampling of our current partners who offer competencies in Windows workloads. And again, if you work with your solutions architect, we'll help introduce you to these people and help you select the right partner to move forward with. The other thing I wanted to point out is on top of the underlying software as a service vendors or prepackaged software, we also have APN consulting partners. So if you need to develop a custom solution or do a systems integration workload, again, reach out to our APN network. We've got a broad range of partners that will help you build any kind of custom solution or system that you need. And we've got thousands of APN partners, and that list is continuously growing. But before I close things out, I did want to mention one other thing that's actually really important. So, of course, everybody has been paying attention to COVID-19 and everyone's trying to achieve work from home. We have just recently announced an initiative called Amazon Workspaces Work from Home. This is a Windows machine. It's virtual desktop infrastructure where you can have up to 50 workspaces for 50 users inside your environment, and they can leverage a Workspaces account for free. Now, this is going to be in effect until June 30th of 2020. And if you actually go to the link that I've got here on this page, you can actually learn more about the offering. But again, the thing I wanted to point out to you guys is this is a Windows desktop. It's running Windows 10. You're able to run your own software on top of this. And this becomes a box that then your work from home users are able to use as a corporate desktop, as opposed to having to leverage their own infrastructure, which may or may not be properly patched or may not necessarily be the security tooling, may not have the security tooling that you would prefer to have. So please look into this. So just to close out, because I'm almost at the end of my time, what did we just see? Well, again, we've had the most experience running Windows on top of AWS. We've developed our infrastructure from day one to be highly resilient, highly available. We've got the best performance and the best set of options that you can for running your workloads. We've got fantastic tooling for migrating applications. And again, we'll be talking about that in depth in this upcoming session. We've given you lots of tooling to make it very easy to operate your workloads inside AWS. And we also have great tooling for developing custom applications or modernizing your existing .NET applications. Really, this list will continue to go on, but the question you really should be asking yourself is, why would you run your Windows workloads anywhere else? And with that, that brings me right under the wire time-wise. So I'm going to go ahead and close things out. I won't be showing the remainder of the things in the appendix. But thank you guys very much for letting me talk to you folks.
Oh, great. Thanks so much, Andy. A couple of quick questions. First, I'm going to do my normal poll at the end just to get some quick feedback, if you could, on Andy's talk. Second of all, maybe one quick question that Carl was asking. Are there any fees with running these agents on-prem or the patching agent?
So great question. So I didn't mention that, and I'm glad you asked. So with Systems Manager agents in your AWS instances, they are free of charge. But that's a good question. For on-prem instances, there is a nominal charge for running an SSM agent on that.